In this video, we're going to look at just a couple of problems from Chapter 2 in our Kaplan SAT course book, the one that deals with linear equations. It's by student request. We're looking at questions 2, which one is the other one? 5 and 6. Okay, let's start with question number 2. This one states, okay, hardware store sells light bulbs in different quantities. Graph shows the cost of various quantities. According to the graph, what is the cost of a single light bulb? Okay, well, first things first, whenever we have any kind of linear graph, we want to make sure that we match up the axes. So it looks like the horizontal or x-axis represents the number of light bulbs, and it's the vertical one that represents the cost. Okay, so really all that we have to do is we just pick, basically it's going to be too difficult. See, here would be one, we want to find the cost of one light bulb, right? So that would be somewhere here in the graph. But it's hard to see where that matches up on the vertical axis. So what we should do instead is maybe pick a point that is provided for us on the graph, and one that would match up very neatly with some sort of exact number on the x-axis and an exact number on the y-axis, and begin there. So I think this one looks pretty good. Let's take this point right here. Okay, at this point, that represents 10 light bulbs. So we have 10, I'm going to put L for light bulbs. 10 light bulbs is equal to, the cost is this line right here. Okay, so then all we'd have to do is figure out, okay, it's between 15 and 20, how many spaces are there? I think it's $1 a pop. Let me see. I think it's 16, 17, 18, 19, 20. Yeah, it's $1 each. Okay, so that represents, that line right there represents $18. So we have the cost of 10 light bulbs is $18. So now we've created our equation. All we'd have to do at this point is, since we're just trying to figure out what's the cost of a single light bulb, we could divide both sides by 10. And that would give us, well, 10 divided by 10, that's just 1. So one light bulb is equal to $18 divided by 10. We could pull out a calculator on this one, because we're allowed to, since the little symbol, but I don't think we need it. 18 divided by 10, that should be what, $1.80? Just drop the decimal back one spot. Yeah, that's it. Okay, so our answer is going to be B. Again, the takeaway here is identify the axes, and then find a point that matches up neatly on either end, the vertical and the horizontal. Okay, very good. Let's move on. So for this, I don't know what that weird splotch is. That's okay. So for this next question, we have this equation here, where it says the equation has infinitely many solutions, and C is a constant. Well, infinitely many solutions is code, and we'll talk more about this as we progress in the course. But that's just code for both of these sides need to be exactly the same. Okay? So we just need to figure out what would C have to be such that this side right here is the same as this side right here. Let's just take a look at this for a minute. Let me expand this out. There are a couple of ways that we can tackle this, but again, on the SAT, you're always looking for a shortcut. It may not mean that you have to do crazy math in order to solve it, which this would be a little bit uncomfortable, because you'd be dividing by by fractions and so on, if you're going to do it the straight up math way. But let's just look at this for a second. Okay, this is a common trap. So C is matching with the 2, right? So a temptation would be to say that, well, those two are the same. Well, they can't be, because the inside of the parentheses for these are different. So here's what I would always suggest first. First thing I would do is think about what would you have to do, before even expanding anything out, what would you have to do to make these parentheses the same, the contents of them? Now let's look at this for a minute. This is a little bit weird because we have minus 2 over here, minus 5 over 2 here, and x over here. But what I would try to do is, let's look at this. I would take the easiest one to work with, I think, would be to try to match up the x's, right? This is just 1x, and this is 4/5 x. So I could do a couple of things. I could maybe multiply the inside here by 4/5, and that would make the x's the same, and we could see what would happen with this. Or maybe I could change the 4/5 into 1. I think I'd have to do multiply by 5 over 4. Either way, it doesn't matter either way. Hopefully I'm not losing you, but here, let me do it in purple with this one. I'm going to multiply everything inside the parenthesis here by 4/5. So that basically means I'm doing this. I'm going to multiply this whole thing inside by 4/5. And just think about that for a minute. Because remember, distributive principle. If I have a 4/5 outside here, I can just distribute that right across those terms as we go. Okay, but if I do that to this side, if I multiply this side by 4/5, I have to do the same thing here. So I'm going to put 4/5 over here as well, right, in order to keep these equal. Hopefully this is okay. So now, if I distribute, I'm going to leave the 2 just hanging out by itself for a minute. But if I distribute the 4/5 inside these parentheses, let's see what we end up with. Let's see what happens. Well, so the 2 would stay outside, but I'm going to distribute the 4/5. So it will be 4/5 times x. Well, that's 4/5 x, right? Okay, so far, these two match. This one and this one. But let's see what happens when we do 4/5 times -5/2. So that would be this. Negative 5/2 times 4/5. Oops, that looks like a 1. Sorry. Times 4/5. Okay? Well, what's that? Well, looks like we can cancel off the 5s, right? So that these cancel off, leaving us just with -1 on the top here. And it looks like I can do some reduction here with the 2 and the 4. Cancel that off. This becomes 1, and this becomes 2. So it looks like this whole thing becomes 2 times 4/5 x minus 2. Right? Does everybody see that? Which is exactly the same as the parenthesis here. Both of these, all these terms are the same. So what that means logically is if both of these equations, this one and this one, have to be the same, then that tells me, here it is, here's the big finale, that tells me that 2 must be the same thing as 4/5 c. Pause the video if need be to just reflect on this. But this is a classic SAT trap. They want you to do more work than you have to, but typically what you can do is try to make, if they say that we know that both of these things are supposed to be the same but they look different, there's probably an easy, quick multiplication that you can do, or division, that would make those things the same. And we found it here by matching up the x, the 1x, and the 4/5 x, transforming those, and that magically also had the same effect on the -5/2 and the -2. Okay, but anyway. So we're at this now. Well, now we just have to solve for c. Well, now it's relatively easy. All we have to do is get rid of this 4/5, and so that would just be multiplying it by 5/4. Right? Because that would cancel this, that, and this, leaving us just with c. But then again, because we have an equal sign, we have to do the same thing here. So that would multiply that by 5/4. Well, what's this? Well, that's just going to be, I could cancel it off a little bit, right? That would be 1/2, right? That would be 5 times 1/2. That'd be 5/2. And there's our answer. Answer is D. Okay? I know this video is running a little bit long, but let's try to do one last one. This one's going to be a little bit intense, but we skip around somewhat. Okay, let's try this one. This one is number 6. This one says if A is a rational number where it's greater than 1, so basically it's a positive number, right? Which of the following could be the graph of y equals ay plus ax plus x plus y? Okay, this is going to be kind of irritating, but let's look at this. Let's look at our options here. It looks like the first one we have a positive slope and a negative intercept. The second one we have a negative slope and a positive intercept. This one we have both a negative slope and a negative intercept. And this one looks like, okay, just right off the bat, hopefully everybody can see we should be able to eliminate this one. That is the shape of an absolute value equation, which we do not have here. There's no absolute value symbols. So we should just be able to, right off the bat, scratch that one out. Okay, so it's going to be one of these options here. So let's see what we can do. We know that the basic format for the equation of a line is going to be y all by itself on one side is equal to the slope x plus some sort of intercept. So let's translate this into that format. All right, so here's what we start with. We have y is equal to ay plus ax plus x plus 1. Okay, and again, let's not get freaked out by the fact that we have all these weird variables here. We just use algebraic techniques, and it doesn't matter what this stuff is. The method is always the same. Okay, so first step would be, let's get all the y terms on one side. Because notice how in our master equation, y is always just hanging out by itself. So we have a y here, and we have a y here. Well, technically an ay, but whatever. So what I'm going to do is I'm going to subtract ay from both sides. So that's going to get me to y minus ay is equal to ax plus x plus 1. Okay, again, a little bit strange, but that's, it's fine. Second thing we can do is we have y and y here. Let's factor the y out from this term. So what I'm going to do is I'm going to do y parenthesis 1 minus a. Take a moment, make sure that you understand how that worked. If I just distribute the y back into those terms, I end up with what I started with. But this formulation just gives me, instead of having two y's, right, one over here, I just isolated it right there and put the other terms inside parentheses. Okay? I'm going to do the same thing for the x, because I have an x over here and an x over here. So let's factor those out. That's going to be x times a plus 1. And then plus 1 over here. And again, think about it. If I redistribute that x across the a and the 1, I end up right back where I started from. Okay? Now, last step. Let's get the y all by itself. And the way that we can do that is just divide everything by 1 minus a. So let's do that. Let's divide this by 1 minus a. Divide this term by 1 minus a. I know it's looking weird, but just hang in there. These are just numbers. 1 minus a. It's the method that matters. Okay, so that means that cancels out, leaving us just with, let's switch colors up again. We'll do brown. So now we have y is equal to x, and again, let's just not freak out. We'll just put it down. A plus 1 over 1 minus a, and then plus 1 over 1 minus a. Okay, I know this looks awful. Like, what in the world is this? Okay, but let's just back up just for a moment. This should be, hopefully now, should be relatively straightforward. We know that a has to be greater than 1. So a is some sort of positive number. So let's think about this. I'm going to box them in. This box right here represents the slope, right? That's the m part in our mx plus b. This part right here represents the intercept, or the b. And really all we have to figure out is the m going to be positive or negative, right? Because if it's positive, it's going to be going upward. If it's negative, it's going to be going downward. And then we just got to interpret the b. Is it going to be positive or negative? Because if it's positive, then it's going to be something like a point here. If it's negative, it's going to be like a point here. We just have to figure this out. Okay, so let's look at this. Well, if a is greater than 1, the top part is going to be positive, right? Let's just pretend a is equal to 2. Let's just pick a number right there. Let's just try that for a minute. So if a is equal to 2, what does this become? Well, the top part is going to become 2 plus 1. That's going to be 3. And the bottom part here is going to be 1 minus 2, which is going to be negative 1. So that tells us our slope has to be negative. So that means a is out. It's got to be either b or c. And then the last thing that we got to check is just, all right, if we picked a as 2, plug that in here. Let's see what happens. Well, we have 1 over 1 minus a. That would be 1 over 1 minus 2. That is equal to 1 over negative 1. So that is negative, meaning we have a negative intercept. So that means this one is out, because that has a positive intercept, right? It's got to be this one. And there's our answer. Hopefully that was helpful.